All right. Hello, chat. Put some music in the background, I think, for myself. I don't know. Where do we be? Where do we be? Where do we be? Spotify? Is that what we're going? Spooty? Spooty? Sure, let's go Spotify for now. Come on, Spotify, load, you bastard. Yeah, I was listening to Black Flag fucking. Let's see here. Focus Flow. Let's go with that. See if this is any good. Ooh, that's pretty nice. Let's go with this. Sure. So hi chat. We're doing. So I have a compulsory lab thingy coming up here. This one here. The hands-on exercise. To read through a thing there, and then I want to start on this thing here a little bit. These ones are later, if I understand correctly, and as well as these guys. That's what I'm understanding it. Wait, let me. Wait, where's the gain? Let me just pull up the gain slightly, because I generally find that I tend to speak pretty softly. So I should probably just speak a little louder, something like this, maybe. I don't know. I would love to have a fucking mic arm. That would be so good. Then I could actually have it in my face all the time without it being in the fucking way. It's pretty annoying. Regardless, so that's what we're doing here. So we're trying to just go through here and just making sure that I've understood the things. What is on the course material thing? Lectures notes. Content interaction as you find exact reading assignment in the canvas. Yeah. The ebook there. Lecture notes here. We get this in a good. Alright, that's a book, and that's. Where did the lecture notes go? This is a book. Download. Oh, here they are. I'm just dumb, I suppose. Cool. Okay, a bunch of stuff. Scroll. Introduction and kinematics. I'm just trying to like make sure I'm as well prepared for things in general that I'm putting in the effort. Below, we present mostly compendium of an excellent comprehensive introduction to mathematical methods for model-based control and industrial robotic manipulation based on the following textbooks. Yeah. Best of our knowledge, now this book and this book are the most commonly used for university engineering education in English on robot control. That's the revision of this note. We have used lecture slides prepared by Professor Anton Shiryaev for an advanced course in robot control, using these slides and the textbooks by Sponge et al. The course taught several times by Ansrival Freiroch U. Martin at University, Sweden, and the Norwegian University of Science Technology, Norway. Notes have been used by Anton Robertson, I think. This guy, I'm not sure. University of Sweden. The current presentation has been shaped and feedback by the instructors and many students. Can we have like here, but I can still read? Hopefully, oh, my iPad is lighting up. Go away. Yeah. I don't know what this means. Pages of this 233. Cool. Understood. Follow here somewhere. Okay. You know what the nice industrial robot means. Automatically controlled program by multi-purpose manipulated programming in 3 or more axes. which may be either fixed in place or mobile for use in industrial automation applications. Where, according to the International Federation of Robotics, reprogrammable means that its program executable motions or auxiliary functions may be changed without physical alteration. Multi-purpose means capable of being adapted to a different application with different applications with physical alterations. Axis refer to direction used for examples. That is a Revolut. I agree. Prismatic. Okay, wait. Okay, I don't know. I don't know how necessary these things are to read now, but I was curious. Conceptual problems or kinematics, inversion of. Oops, I accidentally. How do I remove this? Go away. Thank you. Yeah, these are the things we will be doing in the course, which we shouldn't be doing right now, if I understood things correctly. There should be a lecture plan somewhere. Let me. Oh god. Yeah, put it here. That's fine. Let me see here. So if we go here, I think should be able to see here. Yeah, introduction overview. This is on Monday. Forward kinematics. Generative Hartenberg convention. Okay. Chapter 2. Yeah. So that's coming up. So what I was just reading here, Peter Core. Wait, this is the book. Why does it look shit? Oh wait, okay, no, it's a design choice. It's like, why is it red here? And I'm like, just look, this is bad. Okay, I'm not. Well, okay, no, it actually makes sense because these things are resting on top of the things, so it's actually fine. When I just initially looked at this thing, it just looked dog shit, but it makes sense. I do think that this, like the empty space here between here, looks a little weird, right? Because it's bigger here than like here. Here it's like close by. Regardless, what a fucking graphic designer. Algorithm in MATLAB. Yeah, there is a fucking a Python version as well, which I don't know. I think I already have or no, not on this computer, but on my other computer, the one I had before. I remember I downloaded the robotics toolbox, and then I never used it, which I had ambitions that I never ever got around to, right? Because it's difficult to self-motivate on things sometimes, and like believe in your own ability to learn things when you don't have enough time to properly learn things or whatever, right? It makes some sense. Okay, but yeah. So the thing I'm mostly concerned about is that I need to make sure that I'm prepared. First of all, I want to start just looking at this thing just a little. I want to get this thing to work. That would be cool. And then want to make sure I am prepared for the thing, which, from what I understand, is this guy here, which literally just read this thing. And I've read through and the material and the robot programming language rapid on the technical manuals page. So from what I understand, read through this thing, understand it, and digest it, which we will do together here, chat. That's the goal. And then that's like it to prepare for the lab thing, because we're gonna go and meet the robots and things, from what I understand. Yeah, that's the vibe I am understanding. Just the next fucking day. Okay, things are happening here, I suppose. And then Tuesday, Thursday. What the wait? Does that fucking? There is no way that has 3 lectures in a week. What? The 8th, the 9th, and 11th. Like, what the fuck? Really? And the 12th? There's no way. What? I need to check the damn schedule. That can't be correct. What the fuck? Can there 4 fucking lectures in a week? Holy fuck, that shit's gonna speed up so quick. That's the case. Then I really should get ahead. Okay, wait, let me check next week. So there is one there, one there. So the first 2 days there are. That makes sense in my brain. Like, that's fine. Both courses have 2 each, right? Wait, so this fucker here, 11. There's an lecture on the 11th. What the fuck are you talking about? At the very least, I can't fucking see it. Room MO. On 9/11, or yeah. There's a fucking here. What? There should be a Friday as well there, which is just not. You don't check the next week there on the 16th. I don't understand what this means. Oh, that's for okay. Okay. So the applied robotics for architecture people don't go on these two, and then I don't go on these two. Okay, that makes sense. And then this one is for all of us. Okay. That makes more sense. That makes a lot more sense. Robotics and manufacturing transforms, and then they do the thing here. I don't know. What are the architect people doing? I guess they're not. They don't seem to be doing as heavy of like the math stuff, which I guess makes some sense, you know. But still, okay, cool. I have those two here. This one here and here. By the looks of things. Yeah, okay. Things. Why even is this a thing? Why do I have access to this old information? I don't need it. It's 22 and 23 and 24. Why is it even on here? What? I guess for future reference. Wait, I can find the slides. That's like semi-useful. Because this guy's here. We just don't. I mean, I have the slide for this fucking guy, but that was 2 days ago. Or whatever. So yeah, I can really look at that, which is good. That's a good idea. Okay, regardless. Cool. Now we know what the plan for the week is. We're gonna get into this thing soon enough. Cause this is here, and I want to start just like tinkering with it a little bit. I want to make it work virtual. That would be cool. We're gonna read for this thing and the whole. I think I want to. First of all, I'll move you guys slightly further away. Hope you guys can still hear me okay. From what I can hear myself through the feedback, it should be fine, but it's always a little hard to know. But check OBS real quick. And that is set up to be the whole thing, so should be good to go. Hopefully, chat. If the audio is dog shit, you could argue that doesn't really matter. No one is watching this thing anyway. I kind of want you guys like. It feels like there's like fucking cables everywhere. If I put you like there, that's sort of where my head will be. But also, this is so fucking scuffed, man. Okay, can you be like this? Does that sort of work? Chat, I'm back. I'm sorry. I fucked up. All right, like this. This mostly works. I need to get a pop filter because I'm going pop. You know that sounds terrible in the microphone. So I sort of speak like next to you guys essentially. So I have like a ba out here, just ba. You know that ba's more in. I need a pop filter. I can put a fucking sock on my microphone. That would work. That's the old classic. So this thing here is this thing here, which is this thing here. I'm gonna do these things too, but fucking shit, go away. So first of all, one thing I want to do is I want to add the fucking slides to this thing. So it seems like a good idea. Yeah, let me do that. So I'm doing a bit of just adding things to the thing. Let me see here, chat. So it is applied robotics. It should be here somewhere. Lectures probably. There's the slides. We could compare them. I'm not going to. Let me see. Here is add them here. Open, sure. Yeah, now I'm probably just gonna download the old ones from last year. Right? They're probably going to change, but they're not going to change that much. On the challenge, shall I? Okay, so now I just have all the things here. Scroll, scroll, scroll. Very cool. And some exercises in Robotlab. I don't think I'm supposed to like do anything else in there, from what I understand. Robot Studio, MATLAB. Should get MATLAB doing as well. Peter Cork's Robot Academy. There's a link there. Let me just find that. Peter Cork.com. Let me just go to petercork.com for a moment. Petercork.com. And resources. Oh god. Resources. Robot Academy. Here we are. University level short video lessons and online courses to help you understand and prepare this technology for the future. Fuck is this guy? Joseph Murad. Okay. Cool. How do I do the thing? Do I click here? No? How do I... What? The cute... the cute Robot Academy provides free-to-use undergraduate level learning resources for robotic and robotic vision. The content was developed for 2 6-week MOOCs that ran in 2015 and 16, which in turn was based on a course taught at KIT. The MOOCs, individual lessons over 200 videos, each lesson less than 10 minutes long, or a master class, a collection of videos around 1 hour in duration, previously lectures. Unlike a MOOC, what the fuck is a MOOC? I need to Google. What the fuck is a MOOC? MOOC. Oh, massive open online course. Okay. All lessons are available all the time. Although targeted at undergraduate level, around 20% of the lesson require no more than general knowledge. The required knowledge on a 5-point scale is indicated for each lesson. This short video tells the story of how Robot Academy came to be. I would like to go into the Robot Academy. How do I do this? Where is... What? Link fucking... So this is an image. How do I go there? This day in robotics. Huh? A women's calculation of anniversaries in robotics. Okay, so September 2nd, Sir William Rowan Hamilton died, buried in Viking 2 lands. What the fuck does any of this mean? You can link. Okay, I want to go to fucking Robot Academy. How do I go to Robot Academy? Robot Academy. Okay, it's on robotacademy.com. Cool. No, it wasn't. This is Lego, which is cool, but not what I wanted. And I am not a kid aged 4 to 14, unfortunately. I fucking wish I was. Can you guys imagine how good my life would be if, like, I could do this as a child? This is all I wanted to do as a child, but I couldn't. And it is what it is, right? I would have thought, I mean, this would have set me up for life, man. I just didn't have the ability to, and it kind of sucked. This link then. No, this is some bullshit. What the fuck is going on here? Okay. I mean, cool, man. Robot Academy, Peter Cork. Peter Cork. Cork. Here we just go to this fucking where? How do I go to the website? Is it here? That was your robot is shit. Your robot is shit. Your fucking website is shit, man. What the fuck? Introduction to robotics, to geometry, videometry, paths and trajectories, measuring motions, robotics arms and things, robotic vision, image processing, into computer, color, spatial operators. Cool. Bunch of stuff. If I go here, just curious. So this minute long, okay. Confused. But cool. Oh, it's cute. It's Queensland University of Technology. Yeah, Brisbane, Australia. Yeah, I love Australia. Shout out. Brisbane is a. I've never been to Brisbane, but like robots in fiction. Cool. Human-like robots. Yeah, I want to work on humans. That would be the ultimate goal. Would be to help the world reach human robots. That would be cool. Probably. It might be the end of fucking civilization or whatever, but it'll also be pretty cool. So we'll have a think about it. Let me see here. This is our guy. I'm just putting up this thing here. The beginning here. Just making sure I have it on my iPad because that's useful. Yes, this guy here. Create a new node, please. Done here. Here. I just don't have a bunch of some videos. I could like stream my screen on my iPad. I won't. It's too much work. A primary reason to buy a fucking Mac would honestly just be to be able to share the screen in an easier way than to set up a fucking Zoom call, right? There's like few really good options that I found when I like looked into it. Maybe maybe I should fucking make my own at some point, right? But that sounds like a fuck ton of work for not a lot of payoff for me personally. Now it might be that other people like it is a problem that needs to be solved, right? So maybe there is something there. I had a old computer. I had to fucking program it. Let me use my iPad screen as the monitor screen. It was laggy as shit, but it worked. It was semi-useful when doing a bit of writing. If you just needed a second screen to like put up some notes or something, right? It was semi-useful then. I suppose. Am I tired? I'm not tired. Tired's not really the word I'm feeling. I'm just like, oh, ugh. Whatever that means. Just make this thing big here. Hopefully you guys can see decently enough. I can't zoom in for whatever reason. I can zoom out. Ah, yes, now I can't reach shit. What the fuck? Why can't I zoom in more? What the fuck? God, I love vector graphics. So useful. Alright, regardless, I'm just gonna sort of scroll on my iPad, and as I scroll on my iPad, I'm gonna like make sure that you guys sort of are aligned with what I'm seeing on here. Motivation, inside and working procedures for industrial robots, hands-on experience, hardware, hands-on experience, software. Other robot brands, working principles are similar for most industrial robots. I don't like industrial robots. That's not true. I will very, 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 very likely work on industrial robots, right? That's just the reality of the situation. It is very unlikely that I will just like not do that, right? Like it just is what it is, and that's fine. Exercises, one's hands-on free computer exercises, which include programming, simulation, and test on the robots. Geometrical and load characteristic data. And then we have a ABB, ARB, industrial robot with some dimensions. This is actually legible on my screen. Okay, yeah, we have a big thingy, which is cool. I don't know if that helps me anyway. And then we have a working range diagram. Do we know how long between the things are? Yes. Pose 8, pose 5, and pose 8. Can we like see the pose 8 then? Is this like a thing we have somewhere? No? Okay. That's fine. Okay, put like this. No. Hopefully you guys hear me well enough. The load diagram. Just like so the distance in L and Z direction is this L and this is Z or whatever. I assume so. In millimeters, so 300 millimeters. So that's 30. Nearly is 1,000, so 0.3 meters, right? That's make sure I'm not stupid. 300 millimeters in meter. 0.3 meters, yeah, exactly. Or 30 centimeters. Wait, that's like nothing. What the fuck? I mean, it is something. So this thing's way smaller than I like sort of expected. Oh, it's fucking big. What the fuck? Why can you only? Huh? I'm confused. Rated load as indication in the diagram. The load depends on where the center of gravity is. I don't think I understand, but sure. Load can be higher, which many times used in industry. So you put the center of gravity on the thing like closer to the arm, I would assume, which then makes it easier to carry. Just fucking leverage or something. Example where it can be used for this. These links just do not work. Just don't. In any context that I've used them in. So those videos are fucking useless. IRC5 controller. Let me just Google IRC5 controller. I'll YouTube it. I'm a little curious what the fuck that even means. Hey, look, that's me. IRC5 controller. IRC robot controller. Okay, I'll just. Okay. What the fuck have I. You guys can't hear the music, but. Okay. Okay, this is cute, I suppose. A little confused, not what I was expecting. Okay. I could actually pull up my stream just to make sure that audio is fine. Let me do that. On my second account. Or I should put my primary account. If I just go here. I'm a little low, actually. Do I need to fucking. How much do I need to increase this goddamn gain? Well, it's fine. It's fine. Alright, this in here, I literally can't do anything about it. There might be some settings in here. This thing like set to low somewhere. Now I'm feeling like the mic, not like it's clipping. Yeah, my microphone is in the thing. Microphone. Just where it was. Like, what the fuck? Yeah, it's used in here. Alright, there I count since 20 things. Alright, whatever. Whatever, chat. Yeah. So, fuck. Close that thing up. Let me continue here. Yeah, handle safety first. Safety issues. If needed, use emergency stop. Located on the teach pendant on the controller cabinet. I don't know what a teach pendant is, but I assume it's here. It's probably not very difficult to find. Do not use a standard stop method. The emergency stop causes extra wear on the robot. That makes sense. Because he needs to fucking stop immediately. Tools attached to the robot can move freely in 3D space. Important. Stay out of reach during program runs. Pneumatic tool, the gripper, is stronger than you think. Stay out of reach with fingers from the gripper when active. Safety functions, the service information system. I'm just like reading it on the thing here for you guys anyway. That's fine, whatever. The system gathers information about the robot usage and determines how hard the robot is used. The usage is characterized by the speed, the rotation angles, and the load of every axis. That makes sense. If you do things fast, that's going to cause more wear. If you do heavy rotations, I assume what that means is, that would cause more wear, and high load would also cause more wear. Everything is making sense so far. The time the robot is in operation. Brakes released is indication on the flex pendant. Don't know what that means. Data can also be monitored over network using example webware. Active safety system. Active brake is done. Self-turning performance, power mode, speed mode. Electronically stabilized path. Overspeed protection, restriction on the working space, collision detection. The active safety system includes those software features that maintain the accuracy of the path of the robot and those that actively avoid collisions, which can occur. If the robot leaves the programmed path accidentally, and if obstacles is put into the path of the robot. Passive safety system. Compact robot arm design, optional electronic position switches. Let me pull this up on here so I can actually read the program. The process robot generation. The process robot generation has a dedicated passive safety system that by hardware construction and dedicated solutions is designed to avoid collisions with surrounding equipment if it integrates the robot system into the surrounding equipment safely. Cool. Internal safety concept. Safety category 3. Detection of malfunctioning component. Selecting operating mode. Reduced speed. 3 position enabling device. Okay, that feels like bad English, but sure. Safe manual movement joystick. That makes sense to my brain, right? Because if you want to move the fucking thing, it's a good idea to have a joystick, because that means you have control and you don't have to like physically like stand in the way of the robot, I would assume. You can also like jog it, I think it's called, where you fucking move it physically. Regardless, safeguard stop operations. The internal safety concept of the process robot generation is based on 2-channel circuit that is monitored continuously. If a component fails, the electrical power supply to the motor shuts off, and the breakage engages. Control cabinet and teach pendant unit. Right, here's the teach pendant unit. Is this guy? Yes, it's the teach pendant unit. Why does he look like, if I scroll down here, why does it look like a fucking child's iPad? Doesn't look very cool. Okay, so the main switch, remote control of the power to drive modules. We zoom in further, right? So we have the power button essentially, or the power switch. Emergency stop just above that. If pressed in turn to release. Pressed turn to release. Yeah, okay, people don't know that. That you have to strip it. Motors on. Let's see, just below the motors on button, I think. It probably lights up when the motor is on. Safety chains LEDs option. Can't fucking see, but yeah, they're probably there, and they probably do something. USB connection. Oh, that's a USB connection. That makes sense. Operating mode selector. Where's the USB connection? There's the USB connection. That makes sense. Couldn't they have made a fucking picture bigger? My god. It's in there somewhere. The H is the service PC connection. It's the duty time counter and service outlet. Some of these things I can see on the pictures. Display, that is a display. User defined keys. Okay, so you define what those buttons here do. Or here. Emergency stop button, good, that's there. This is a joystick and this is program execution keys. So go forward, backward, stop and play. Enabling device backside. And moving the robots, the push button must be pressed half in, which takes the system to motors on. When released or pushed all the way in, the robot is bottom motors off state. Okay, I think that made some sense in my brain. Programmable keys, start. Where's the start? Oh, we have a backside. Scroll you guys down here. Keys, E is a start button. This guy here, that makes yeah, and then F is a backward, and G is a step forward and stop. This all makes sense. Robot Studio Online is a piece of nurturing. It's a complement to work from the Flex Pendants. Robot Studio Online is optimized for text-based programming. System Builder for creating and installing maintaining systems, the configuration editor for editing systems, the running system, a program editor for online programming, an event log, blah 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 blah. You guys notice that I'm a little bored. A file manager. Yeah, whatever, bro. Like, sure, get it. So use the main switch on the controller. System is quite stable and rebooting is usually necessary, but shut down and turn on if needed. Collision, jump limits, etc. The robot will alarm and stop immediately. Acknowledge alarm on TPU and jog away from area. Right, you fucking just grab the fucker and move in. Some useful operating windows in the TPU. So you like you do the things here. If I scroll you guys down here, there's no things here. Motion mode, code coordinate system, tool. Right. So if we check the things here, the motion mode, the coordinate system, which is useful, which tool is on, work object, which is probably what we're working on, payload is probably what we're carrying, I would assume. And increment, is that like time increment? Time, question mark? Production window used to view the programming code while program is running. PP to main. Can like debug code and shit. Cool. Program data. Functions for viewing and working with data types and instances. Tool data. Which tool data in here? Tool data, tool data, tool data, tool data. Where's tool data? The fuck? Am I blind? Tool load data. Robot target, stop point, tool data. And wobj data is over here. It's like marking them in the things. If I'm looking at them, it's easier to identify them. This is where you can create or modify programs, blah 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 blah. Sure. Resolver revolution. The robot has lost its position on the home position. Looks strange. Tool calibration. This is including in the hand-on exercises and also part of kinematic related exercises. Scrolling and zooming. Okay, a bunch of things. But that's jogging. Let me move you guys here. We go. The jog is to manually position or move robots or external axes using the flex pendant joystick. Just scroll up here and hear the flex pendant joystick. I would assume this, yeah, the flex pendant joystick is the joystick here. This makes perfect sense in my brain. Things are making sense. Booking for lab 1 is now open. You're right. Oh, yeah. I need to remember doing the thing soon. Jogging is done in manual mode. Selected motion mode. The selected motion mode and the coordinate system determines the way the robot moves. Yeah, that makes sense. Jogging can be made in custom-defined coordinate systems, allowing more complicated movement. Yes, you can define like weird coordinate systems if you like need to move things in a certain way. That makes like sense. More on jogging. The joystick response is proportional to how you handle it. So start gentle sticks move to generate gentle robot motions. Hey, that's cool. And then if you like, other robot makers may use push buttons to generate motions instead of joystick. That makes sense. And then if we check the jogging modes in here, yeah. So X, Y, and C is apparently a fucking, you do a circle motion. I assume that's what this means. Joystick direction, axis 1, 2, 3, reorient. A little confused. Default settings, the linear and reorientation modes have default settings for coordinate systems. Sure. Tool, work, object, and payload. Selecting tool, work object with defined where how to move in the workspace. A payload must be defined, otherwise the system will almost always stop due to overload errors. This one is probably important. Payload data is included in the tool data together with center of gravity data. Probably important. Exact values is not critical. Cool. Jog by axis. This is important. Let me like highlight around here or something. Because if we're going to jog the fucker, we need to know which axis is which one. 1, that's 2, that's 3, that's 4. You can scroll here so you guys can see it. This all makes sense, right? So depending on which part you're going to move. Soon to be done, chat. Jog in base coordinates. Base coordinates are defined from the base of the robot and its setup, or mounted upside down. Upside down? Oh, okay, now I understand. Well, coordinates can be defined and used for jogging. But the robot should follow the same coordinates axis motion for any jog instruction. Work object, and tool coordinates. Define frames from object to okay, wait, let me actually read this. Define frames, work object frame. These frames can be used during jogging. This is useful when motions are defined with references to work object or tool. That's like cool and important. Right, so you can move things in relation to objects, which is useful, right? Which usually is the tool or the object that you're trying to do with the thing with the tool. Use the incremental movement to jog the robot in small steps, which enables very precise positioning. This is important to avoid collision close to other objects. 0.05 millimeters. That is very small. Positions are always displayed as the points in space expressed in X, Y, and Z. And see tool center point coordinate. This is important here. The angular rotation of the tool center point expressed in Euler angles or as quaternation. Creating a tool. The TCP, the tool center point. TCP robotics meaning. I think it's tool center point. Tool center point, yeah. Robots and effector tool serve as references to the movement. Yes. My brain is activated, chat. My brain is activated. So we're checking here now. Tool definition menu, right? So we can set up our own tools. Tool 1, global, persistent. We assign it a task. module and things. Okay, dimensions. Okay. Define a tool frame. TCP can be defined in many ways. Okay, here the 4-point method is shown, where the robot is positioned around the same point in space. The robot then calculates the TCP automatically. Right, so you put the robot in these 4 places. I would assume that's what that means. Can be defined in many ways. Here the 4-point method is shown, where the robot is positioned around the same point in space. Okay, so if we just place the robot in the same point in space through different orientation, he figures out what the TCP is. Motion and interpolation during execution. Joint interpretation, move J. Used to move tools quickly from one position to another. This is important. Move J and move L, because the J is you move the joint, right? Or with the joint interpretation thing. Used to move the tool quickly from one position to another, used when the path between points is not important. Allows movement for any location in a single movement. Allows movement to any location in a single movement, right? The velocity is defined in millimeters per second, but will only be approximate. All axes which moves will be stopped at the same time. Yeah. So you let the robot move however it wants to move in order to get to that new point the fastest way possible. Let me write that down. Get the robot from point A to B in, I don't know if it's necessarily the quickest path. Linear movement in Cartesian space. Movement may not be possible due to joint limits. That's important to remember. The paths and velocity for singular areas may be different from defined. What? The path and velocity through singular areas may be different from defined. What's the point then? Aren't we supposed to have linear interpolation, so the path and velocity shouldn't be different? Or maybe I'm misunderstanding what that means. Any reorientation of the tool is made at constant velocity. Yeah, that's the whole point. Or are you just saying that our robot is shit because it can't hold the fucking speed the same? What? Or are you just saying that, what is that saying actually? A circular path is defined by 3 programmed poses. A full circular circle requires 2 moves C. Right, that makes sense. It's a half circle or a parabola. Those aren't mathematically the exact same thing, but they're close. Behavior or any reorientation must be checked. I don't know what that means. Pose, target, and path. Let me just, okay, so this is the last one. I am getting a little tired. Pose, target, and path. Movements can be arguments, which is defined. Movements can use arguments which define interpolation, I can speak, velocity, and how to pass through a pose. A fine argument means a full stop before continuing. A zone value greater than 0 means a flyby motion. I think I understand what this sort of means. So you just, you just go by it close. Oh, this is kind of cool. Yeah, exactly. So you define the little corner thing, essentially, just how you want the corners to move. You have the ability to choose that in a very precise way, which is good, because that's probably important some amount of the time, depending on what you're doing. All right, we're drawing one of the things, right? That's cool. Flyby point, yeah. So you just go from this point to this point in the zone, right? So you fly by the point, just go and get close to it, essentially, is what I'm understanding is that. In the linear interpretation, it essentially draws the straight line between the two, which means you have a slightly different corner. Changing orientation. Yeah, you can change the orientation of things. Is that makes sense or what? Right, and different tools have different uses at different orientations. Like a pen, um, will write differently if you like tilt it in certain ways. Um, and if you have it like very straight, it will be a very small line. If you have it on an angle, it will create a different thicker line, or maybe some like shading and such. The same pose can be reached using different configurations. Yes, this we talked about on the lecture. This makes sense. Specific instructions can be used to define how to reach a pose. Yeah, because sometimes for a given pose, there can be multiple possible solutions, and some of them might be more desirable than others. And when moving from one pose to another, you'd like, or when moving from one point to another, you'd like the poses to be similar, so the robot doesn't do unnecessary movements. Singularities. Singularity at the intersection of the wrist center axis 1, degree 0. Right, so you're... What? I'm not sure I'm following. Hands-on exercise will provide an introduction of the basics of operation and programming robots. Computer exercise will complement this with more advanced tools, including simulation. Making robot programs for complex processes or production systems is an art and requires a great skill from involved personnel. Yeah, it seems fucking cool, and I'm excited about it all. Maybe I will dedicate my life to be a robot programmer, you know? Maybe. Who knows? Who knows? Right. So hopefully that's like it, or that's the thing that we're doing here. From what I understand, this I was supposed to read through this thing and like eat the information, and I feel like I have mostly done that, at least somewhat. I've barely read through it pretty thoroughly, like 1.5 times. So I got somewhere in the middle yesterday, and it's like, okay, I'm sort of done for now. Then I came back today and I read through the entire thing. I made some very small notes and things in my thing. Good. So that feels good. I don't think I'm supposed to be doing anything else. I discuss with them and topics in the stand during the exercise. Yeah. Which you sign up for together with the first. Through it in advance. Yeah. So yeah, that's that. I think that's that. I hope that I've understood this correctly, and like that's just what we're supposed to be doing. Things we can read through here. 700-page book. I am enjoying what I'm doing at the very least, like quite greatly. So that's nice. But yeah, this was a bit of a slog, which makes sense, right? You're just reading like basic orientation, which is really important, but sometimes it's not the most fun thing or the most engaging thing to do, which is completely fine. And these things are for later, and these, yeah, this is another guy, if I understand correctly. Yeah. I think that's it for that thing. And then I need to, first of all, I want to do some reading on the things. I want to do a little bit of watching on here, I think. I know there are some YouTube videos I'd like to watch, but that's not super like it's not super great content, right? I'd probably switch the I would like to switch the camera angle and such then. But it has become well. Just probably turn stream off. Probably bring some food to school. I'm thinking about going to campus because sitting here at home, like it works, right? But it's pretty nice to go places, you know. If I were to just bring my food with me and put it in the fridge, because then I can eat it later. It's fine. Like it's not as nice having to put it in the microwave compared to an air fryer. That's completely fine, right? I'm not gonna, right? Because then I can be in the student part of the chemist building, where they have both a fridge and a microwave, which is pretty cool. So yeah, I wonder if you can make a lock picking robot. I mean, you definitely can, right? But I wonder if that would be like, can I like do that as a robot skill? Or like a mechanical arm? That'd be kind of cool. What if it is for robot hand? I don't think we have any cool robot hands with big doffs. Yeah. So I'm thinking about just closing up the stream here, calling it quits for now. Deciding what I want to do, and I'll probably go to school. I think it would make sense, right? Because I had lunch earlier today. And then yeah, then I turned the stream on, then I did this thing here. Oh, I've been streaming for like 45 minutes. Oh, almost an hour. Cool. Right. So that's sort of where my head's at. Because then I could bring those things. Cause I have a fucking little like YoPro fucking protein pudding in my fridge that I could bring and I could eat in like an hour or so, just to sort of tide me over until like 6, something like that. Somewhere around there, and I'll have my meal of the day. Well, actually, right. Well, if I bring the soba, and I have lunch for tomorrow, which would be nice. But if I'm going to, sort of thinking, cause my plan is to. My plans changed a little earlier today, chat, because I was going to my parents on Friday evening, and I was like, okay, yeah, well then I'll eat food with them, right? But then plans seem to have changed, where I'll probably go to them on Saturday, which is fine. I know why, but then I'll need to eat one more meal, right? So I need to account for that. I think I have some food in the fridge. I can probably use it. It will be fine. But yeah, sort of my head is at the moment. I have chicken in the fridge that I need to do something with soon enough. I'm not in a hurry to use it. I'll probably do something with that on like Monday. Hopefully, remember to take it out on Sunday when I come home. Yeah, I'm gonna try to be back in London on Sunday. That would be nice. Right, 'cause I could go home on Monday morning. But like the risk that just like the first 2 hours of that morning is just destroyed is pretty high. Because if you go here, oh wait, no, I have a lecture at 8 actually, so I can still go and do the thing, right? But it would just be to go home after lunch and such. I wouldn't have food at home. Yeah, no, it makes sense. I'm going to make some food. Well, I'll just buy some. It'll be fine. It'll be fine. Okay, chat. I think that's it. I'm just rambling at this point. But thank you guys for watching. I hope you enjoyed this nice little run through of the safety instructions for the hands-on exercise in FRT and 85. And I might stream later today. It's possible because should I say? If I go to school and things, or if I go to campus, I can probably turn the stream on there. I probably won't bring my microphone. I might, but I probably won't. I'll think about it. But I'm pretty tired. I think I'm gonna go on a small walk. I think that could help because my eyes are a little fucky wucky. And then I'll decide if I'll probably go to campus. That's probably a really good idea. And then spend the afternoon, probably evening there. That would be epic. Because then I could like get really far ahead in these 2 courses. That would be awesome. That would make me really, really happy. So that's the plan, and we'll see how it goes. So I'll see you guys around. Have a wonderful afternoon.